Hey everybody, welcome to another installment of the Chemical Engineering Editor's Roundup, where we take a quick look at some of the content that we have in our forthcoming issue. I'm Scott Jenkins, Senior Editor at Chemical Engineering, and I'm joined by my fellow Senior Editor, Mary Page Bailey. And we're going to talk about a couple of things, a few things, I guess, in the November issue that's coming out shortly. So this month we have a cover story on mixing, and there were actually two different mixing articles. So, Mary, will you just talk about the one that you edited?
Yes, thanks, Scott. So the article that I had that was part of our cover feature on mixing specifically talked about different kinds of mixing technologies that are used throughout the steps of lithium processing. So this article goes through the mixing steps that are used throughout the whole lithium purification supply chain. So that includes crystallization, that includes carbonation, and that includes the decomposition and the carbon dioxide removal from the process. So this article gets pretty in depth on the mixing equipment, the stirred tanks, different agitator and impeller configurations, different kinds of baffles inside crystallizers. So if you're doing anything involved with lithium compounds, especially in that purification step, focusing on crystallization specifically, or if you operate in any sort of process that uses these similar kinds of units, definitely check out this article for some really excellent guidelines and insights about best practices. And Scott, you had another mixing article I know that
Yeah.
was kind of related to this one.
Yeah, thanks. So that one, the one that I edited was more, kind of more fundamental a little bit. So this one focuses on the forces that are acting on impellers within mixing vessels. So the article talks about things like torque and bending moments, the two loads that you'll often see on impeller blades. But it really gets into how to calculate the hydraulic force. The hydraulic forces fluctuate in magnitude and direction, and really are a result of the turbulence in the mixer. So these forces are not constant. So designers have tried to figure out ways to figure out what the peak sizes of the forces are. And this article talks about how to do that, and it actually provides a pretty good example of a calculation related to this. So yeah, good mixing stuff. And then, in addition to our mixing stuff on the cover story, there's also an applied technologies article in this issue. It's actually about a project to install a large scale heat pump at a BASF facility in Germany, and in an effort to kind of move toward decarbonizing the BASF facility. The company BASF and its partners Gig Karasek and Pillar installed a heat pump to convert previously unused waste heat into carbon dioxide free steam. So it's a pretty interesting project, so definitely worth checking out. And the other thing is that we wanted to mention here was our commentator section, which runs every month and always has some interesting stories. So, Mary, do you want to tell us a little bit about some of yours?
Yeah, thanks, Scott. So this month actually was a really busy time in the industry for some major industry events. So we had some good coverage of some novel breakthroughs that were kind of highlighted and announced at these events. So the first one was at the K Show in Germany, which is the trade show focused on the rubber and plastics industries. So the commentator that I wrote about was the company Asahi Kasei has been scaling up a really novel process for recycling carbon fiber reinforced plastics, which normally these are like ground up into little pellets. But Asahi Kasei has developed this sulfuric acid electrolytic process that actually decomposes the resin matrix around the carbon fiber so they can recover these fibers intact so that they can then be reused more readily into the similar applications as to what they originally came from, so they don't have to be downcycled into pellets and things like that. So
Right.
at K-Show, Asahi Kasai proved the scale up by showing, I believe it was around 200 meters of these recycled fibers that were able to be recycled continuously. So they're opening a plant at the end of this year. So that's pretty interesting. The other large trade show that I wanted to highlight was the battery show, which was in Detroit. And I actually was at that show. It was an excellent showcase of a lot of innovations in battery chemistry and the way the supply chain is moving. It's really exciting stuff in the battery industry. We'll have more on that coming. So you can look for more content about the battery show. But the commentator that I wanted to highlight from that was a company called ATO Systems. They actually won an award for top battery manufacturer of the year at the battery show for this ultra rapid curing technology that they have that enables the coating and curing of the electrodes in batteries much more quickly than traditional methods. And this is using something called electron curing, where they have the active battery material that's actually exposed to a controlled beam of electrons. And this allows the curing to happen extremely quickly with no ovens, much less heat and energy. So it's quite efficient, quite a lot of benefits over the traditional methods. And they're demonstrating this at industrial scale with the company Kodak at a facility in New York. So you can read more about that and more about the battery show coming soon. Scott, I know you attended an event this month as well.
Yeah, so I was at WEFTech in Chicago, and that's for those who don't know, it's all about the water treatment industry, water treatment and wastewater technologies, and yeah, there's actually a commentator in there in this issue that comes out of that meeting. It's about as you might imagine, one of the big issues at the water show was the handling of PFAS materials. Um, and there's a commentator in this issue that talks about a PFAS removal and destruction technology that really has evolved to with significant reductions in capital expense and operational expenses for doing this PFAS removal and destruction. So definitely check that out in the issue. One other quick thing I was going to mention too is a commentator about recycling polyvinyl chloride. So we know recycling plastics chemically presents challenges across the board, really, but PVC has had this extra added challenges because of its chlorine content. So a company in Israel that we wrote about here in Commentator has developed this method for using superoxide radicals generated in situ to first dechlorinate the polymer and then break down the carbon-carbon bonds in the polymer chain. So they're actually planning a pilot for 2026 in Ohio. So pretty interesting there for Commentator. So Mary, anything else that you wanted to mention before we sign off here?
Yeah, just keep an eye on our website. We're always posting latest news and new technology articles there. We have some web exclusive features you can read only on our website. Find us on LinkedIn. We're usually keeping everything up to date there with announcements about webinars and new articles coming out. And stay tuned for our December issue where we're going to have some features on cost engineering and solids processing and a lot of other good stuff coming. Thank
All
you.
right, sounds good. Thanks, Mary. We'll see you all next time.